Hello friends, welcome to my channel, myself Parag Jambulkar. In last video, we have seen different characteristic of task. We require this characteristic of task for good mapping technique or to decide which mapping technique or which mapping scheme we require. For that purpose, we require different characteristic of task. In the similar way, in the same way, we require one more thing and that is called as characteristic of inter-task interaction. We are talking about the interaction. So for good mapping technique or to decide any mapping technique or scheme, we have to also consider different characteristics of interaction. So when the task executed, this parallelly executing task, they share some information with each other and that we call interaction. So what type of interaction they have for what purpose? Generally, they share some data with each other or they share some work with each other. So some processes which are finished earlier, so they may get some work from the others. So work is also shared among the different tasks or different processes, and sometimes they have to share some synchronization information to synchronize some tasks. So this interaction happens in between the tasks for sharing some data, often or for some sharing some work, or for sharing some synchronization information. So there are different characteristics of interaction. So these characteristics are: first is static versus dynamic, second is regular versus irregular, third is read only versus read write, fourth is one way versus two way. So we'll focus on first one, static versus dynamic. When these interactions happen at particular time interval, so we say it is a static interaction. So as these interactions happen at particular time interval, so before execution of that particular algorithm, we can know when interaction will happen. So we'll know when interaction will happen before the execution of algorithm, and that's why it is called as a static interaction. While if these interactions are not happen at particular time interval, so we cannot know before the execution of algorithm, we can know only at runtime, so it is called as dynamic interaction. For example, look at this matrix multiplication. Now see, for this task, so calculating this value is one task, calculating this value is another task, calculating this value is another task. So for this task, it requires this information, as all these tasks they are sharing this information. Now before execution only, we know the task require this much information, and we know this when we require this information at what particular time. So this is a static interaction. When we know that when this interaction is going to be happen, or when the task will share this common information or common data at what particular time, so this is called as a static interaction. While look at this puzzle problem, so all tasks what the work is done by the particular task, each task take an input state and they find out the number of steps to reach to the goal state. At that time we are not knowing how much computation is done by particular task and how much data they require from the another task. So here only at runtime we'll come to know how much interaction is done. So that's why puzzle problem is an example of dynamic interaction. So matrix multiplication is an example of static interaction, while puzzle problem is an interaction of dynamic interaction. So static interaction in the sense we are knowing when interaction will happen, we are knowing what is the time of interaction, while dynamic interaction in the sense we are not knowing what is the time of interaction, so only at runtime we will come to know what is the time of interaction between the different tasks. Now we will see another characteristic of interaction, that is regular versus irregular. It is just similar to static versus dynamic. when interaction have some particular pattern or when interaction follows some particular pattern, it is called as regular interaction. While if interactions they are not following some particular pattern, this is called as the irregular interaction. Particular pattern in the sense at what time data is shared and how much data is shared. If there is a particular pattern, then it is called as a regular interaction. On the other hand, if there is no particular pattern, if we are not knowing at what time data is sent, at what time data is shared, at, and we are not knowing how much data is shared, then it is called as irregular interaction. For example, look at this. Here we are multiplying one matrix with one vector and we are getting a resultant matrix. So here we are knowing at what time data will be shared among the different tasks and how much data is shared. But if it is a sparse matrix, so general multiplication of one matrix with an vector is an example of regular interaction. But if our matrix is a sparse matrix in the sense if there are more entries of zeros in this matrix, then there will be irregular pattern for interaction among the different tasks. So if it is a sparse matrix, then the interaction pattern will be irregular. So we'll call it irregular interaction. Third characteristic of interaction is read-only versus read-write. From name we'll come to know. When tasks they are reading from the shared memory, from the common memory, and they are just reading the data, then it is called as read-only interaction. Just they are reading from the shared memory, so that is called as read-only interaction. While when the task they are reading the values and also they are writing values in the shared memory, then it is called as read-write interaction. For example, this matrix multiplication. So this is one task, this is another task, this is third task. All the tasks they are reading the values for this vector. All the tasks they are reading this value from the shared memory. So they are reading the values from the shared memory for this particular vector. So this is the read-only interaction. When the different tasks they are just reading the values. While look at this puzzle problem, each task they are reading the values and also they are making some changes in the data. So for example, look at this. At this step, it will move here upwards, it will move to the leftward. So they are also writing into the shared data. So that's why it is a read and write interaction. So it's very simple. From name only you come to know. When the task just they are reading values from the shared memory, this is called as a read-only interaction. And when the task they are reading and at the same time they are writing into the shared memory, so such kind of interaction is called as read-write interaction. Another characteristic of interaction is one-way versus two-way. From name we will come to know. When interaction is started by one task and it is not affecting another task, then it is called as a one-way interaction. While if both the parties or both the tasks they are actively participating in the interaction, then we call them two-way interaction. Read-only interactions are one-way, that it is not going to affect another task. While read-write interaction, it can be one-way, also it can be two-way. So these are the different characteristics of interactions. Out of these, static, regular, read-only, one-way are simple one and they are easy to program. While dynamic, irregular, read-write and two-way are complex and are difficult to program. So friends, I hope you like this video. If yes, then click on like, subscribe to the channel and don't forget to press bell icon so that you will get notification of my next video. So stay connected. Thank you.